Hey guys, this is Mr. Gran, and this is 8.4 Rational Functions. In this video, we're going to focus on horizontal asymptotes. Alright, so when it comes to horizontal asymptotes, they don't come from the factored form, they actually come from the regular form, or that's how we find our horizontal asymptotes. We find these by looking at the degree of the numerator and comparing it to the degree of the denominator. We want to have them in standard form so we can just take that first term. Then we don't have to worry about any of the other stuff. And there's three possibilities here. One is if it was no asymptote. So that, for example, that is if the degree on top is bigger than the degree on the bottom. So that would be if we had something like x squared minus 9 over x plus 2. The degree on top is larger than the degree on the bottom. When that happens, there's no vertical asymptote, or no horizontal asymptote, I should say. If the degree on the bottom is bigger, it's automatically going to be y equals 0. So that if we flip that last example, if it was like x minus 2 over x squared minus 9, now the denominator has the bigger degree, and that's automatically going to have a horizontal asymptote at y equals 0. And then the horizontal asymptote is at y equals the leading coefficient over the leading coefficient if they have the same degree. So that LC stands for leading coefficient. In that case, that might look something like this. So let's say we had like 2x squared plus 3 over 3x squared plus 4x minus 1 or something like that. Nothing factors, nothing cancels out. Same degree on the top and the bottom. That is going to have a horizontal asymptote at y equals 2 over 3. Okay, so looking at some examples, something like this. We've got the same degree over the same degree. And so that is going to have a horizontal asymptote at y equals the leading coefficient 3 over the leading coefficient 4. So I'm just taking the number in front for each of these. All right, number 2. Now it's a higher degree on top. It's a degree of 3 over degree of 2. And so that is going to be none. There's no horizontal asymptote. Number 3, it's the higher degree on the bottom, so that is going to be at y equals 0. And then number 4, this is kind of a tricky one because it's not in standard form, right? The degree of the top is actually 4, and the degree of the bottom is actually 2. So it's the higher degree on top again, which means that there is no horizontal asymptote. All right, so now a little wrap up. Just identifying all of the things in one problem. This is basically the problems for this section are like this. Identify all of these things based off of just one rational function. All right, so we'll start out by factoring the numerator, and that's going to be at plus 3 minus 2. And so we have some factors that cancel out. Now, one thing that is handy for this, if you make yourself a little cheat sheet that looks like this, these are the things that we're looking for, where they all come from. So if it is a factor from the top that doesn't cancel, that's going to give us a 0. If it's a factor from the bottom that doesn't cancel, it's going to give us a vertical asymptote. And if it's a factor that cancels, it's going to give us a hole in the graph. So the 0 is at 0, negative 3, and that comes from that x plus 3 on top. There is a hole in the graph, and the x-coordinate is a positive 2. And to find the y-coordinate, what you're going to do is actually take that positive 2 and plug it back into the simplified equation. So what we'll do is we'll take that x plus 3, right? That's what this simplifies to when we cancel out the x minus 2. And we're going to plug in that positive 2, or we're going to attempt to. And that's going to give us the y value for the hole in the graph. All right, vertical asymptotes, in this case there are none because the factor on the bottom canceled out. And then our horizontal asymptote, looking at the degree of the top versus the degree of the bottom, there is also none.